predicting the products, and you were going to do that third one for practice. But we need to think about what's actually happening when we dissolve an ionic compound in water. So remember, AQ means dissolved in water, and based on the solubility rules, we can see that a few of these compounds are aqueous. So sodium chloride is aqueous, copper 2 chloride is aqueous, and sodium nitrate is aqueous. Whereas calcium carbonate is a solid. So when these things are dissolved into water, what actually happens is they dissociate into their ions, and I'll write that in a second. So this is like if you have a marker and a cap, you can dissociate, you can break apart the cap and the marker, and you now have two pieces. So that's exactly what happens when you have a solution dissolved in water, or an ionic compound dissolved in water. So the sodium chloride, because it's aqueous, dissociates into its ions, and we get the sodium ion and the chloride ion. Okay, and once you dissolve away the water, those two ions come back together and you form the solid AgCl if there was no water around. But because it's aqueous, because it dissolves in water, what happens is the ions dissociate, they break apart. Okay, any ionic compound that dissociates will break into its ions. So copper 2 chloride, right, CuCl2, it doesn't break into two pieces, it actually breaks into three pieces. Right? So think about a marker with a cap on both ends. If you wanted to break it into all of the pieces that are easily recognizable, you would get one marker body and two caps, three individual pieces. So we get one copper ion, copper 2 ion, and two individual chloride ions. So that 2 as a coefficient is important because it says that the chlorides are not bonded together, which should make sense to us because these are ions. These are two negative anions that do not want to be hanging out together. So we just create multiple pieces. So like if you were to take a unicycle apart from its frame, you would get one wheel and one bike body. If you were to take a bicycle apart, you would get two wheels that are separate from each other, right? They're not bonded together. You can move one independently from the other, and you get a bike body. So if we had two sodium nitrates, right, we need to think about the ions that are present in sodium nitrate, and what does that 2 in front represent? So we would get two individual pieces. We get the sodium ion and the nitrate ion, right, for each individual compound, but there are two of them that break apart. So now I'm taking apart two unicycles or two markers, right? I would get two caps to the marker and two bodies to the marker. So here we get two sodium ions and two nitrate ions. Okay, so this is, we're just representing what's actually happening in this reaction, or what's actually present in the solution. We don't have sodium chloride anymore. We have sodium ions and chloride ions. That's what it means to be aqueous. Calcium carbonate, on the other hand, is a solid, and solids do not dissociate, into their ions, so calcium carbonate does not break into its ions. Okay, things that are solid stay together, and that's why you're able to filter them out of solutions. Okay, so this goes into, we're going to get into something called the net ionic equation, and in order to get there, we need to think about different types of equations. So equations that we've been writing so far, every chemical reaction you've written is something called the molecular equation. It's where you have all the compounds in their neutral form. Okay, you need to make sure that your equation is balanced, but we know that. Anytime we see a reaction, we need to balance it. So here would be a molecular equation for silver nitrate reacting with barium chloride. We see that this is double replacement because the silver and the barium have switched places with the to hang out with the new anions. So we have silver nitrate, barium chloride, both aqueous, and then we form barium nitrate and silver chloride, which is a solid based on solubility rules. Okay, so this is a molecular equation. It should look very similar to all the equations that you've been writing before. Okay, then there's something called the complete ionic equation. This is where we are going to represent what's actually happening in our solution, right? So if there's an aqueous behind the compound, we break that compound into its ions. If there's a solid or a liquid, we leave it as is because we're trying to represent what's actually happening. So from the reaction that we had, I'm going to go back real quick. Right, we see that silver nitrate, barium chloride, and barium nitrate are all aqueous. So they all get broken into their ions, right? There's 2 silver ions and 2 nitrate ions, a barium ion and 2 chloride ions, and on the other side we have barium and nitrate ions, and the AgCl does not change because it is a solid, okay? So that leads us to this thing called net ionic equation, where we cross out the spectator ions, which are the ions that are exactly the same on the left side as they are the right side. Okay, and then we're going to rewrite the equation with everything that's not crossed out. So here is our net ionic equation, or our complete ionic equation. Nitrate is the same on both sides. Barium is the same on both sides. So we cross them out because they didn't change chemically. Right? These things are exactly the same on one side from the other. They are just watching, right? They're spectators. They do not interact in the reaction. So what we would do is we would now rewrite our reaction with the substances that did change, right? We had aqueous silver and aqueous chlorine. I dropped that in the equation, sorry. And they're forming now solid silver chloride. So they changed their state. So this is the reaction that's actually happening. And then we can simplify. 2 to 2 to 2 is the same thing as a 1 to 1 to 1 ratio. So this right here, the silver plus 1 plus chloride minus 1 gives us silver chloride solid. This is the net ionic equation. So from that entire equation, the only thing that's actually going through a change is the silver and the chloride. The barium and nitrate did not change at all. Okay, so they were just spectator ions. So that is a quick introduction into net ionic equations. You're going to practice some of it in class, and if it's difficult, I totally get it. But I just wanted to give you an introduction into